Welcome to another unit of the ISM Exercise Set Statistics 2. This time with a unit on the coefficient of determination and F-tests. Let's have a look at the exercise. In the context of a market research project, you are asked by your boss to test whether a relationship exists between the age of a person and how long they watch TV series. In this context, the following table has been prepared during the pre-test. Now we have here for 5 people, age and series consumption. And the task, part A, calculate the coefficients of the regression line that describes the relationship between age and series consumption. And B, in the course of the estimation, you get a coefficient of determination of 0.8. Use a suitable test to test if the calculated relationship is significant at the 5% level. Okay, so first we need the regression line. For this, we're going to copy our table and extend this by an additional row where we calculate the dependent variable squared, so x squared. That's like 15 squared, 225, 28 squared, 784, and so forth. Then we're doing as well x times y, so 15 times 25, 28 times 17, and so forth. Finally, we're going to add 2 columns, or rather, we're mainly here at this point only need the last column, the averages of x, y, x squared, and x times y. Because if we have this last column, these 4 values, we can directly get our coefficients. Here for the slope, it's the average of x times y, so the 415.2 minus the average of x times the average of y, so 29 and 16.4. And all of this is divided by the average of x squared, so 934.2 minus the average of x squared, so 29 squared, giving us here a coefficient, a slope parameter, of minus 0.6481. With this parameter b and the averages of x and y, we can get our constant or our intercept, which here we get as 16.4, the average of y, minus the b we just calculated, times the average of x, the 29, giving us here an intercept of 35.1949. Taken together, we get the corresponding regression line. Okay, so we finished the first task, we got the regression line. So in the second part, we want to perform an F-test to test whether the regression line we just determined in part A explains a significant share of the variance of the dependent variable, so of y. For this, we first calculate our test statistic, which for the F-test is given as r squared, divided by k being the number of independent variables, so here it's 1, and all of this divided by 1 minus r squared, divided by n minus k minus 1, n being here the number of observations. So we have 5 observations, 1 independent variable again, so we get here 3. So we go 0.8 by 1, it's 0.8, divided by 0.2 divided by 3, giving us a test statistic of 12. Then, in addition, we need a reference statistic, and the reference statistic here is given as f. Then we have 2 degrees of freedom. The first is k, the number of independent variables, which is here 1. And the second one is n minus k minus 1. So again, it's here 3. And then we have 1 minus alpha, the alpha being the error term here. And the error, we know we said for an acceptable error of 5%, so alpha is here 5%, so 1 minus alpha is 0.95. If we then turn to the corresponding table for the F distribution, at the point F13, 0.95, we find a value of 10.128. That's the value we need to compare our test statistic to. That's our test decision. Here we see our test statistic is larger than the reference value. Thereby we can reject H0. The H0 hypothesis here is that the model we just determined in A has no significant explanatory power. Or in other words, all the coefficients at once are equal to 0. So here, if it's rejected, we know the model has significant explanatory power. Yeah, and this then concludes this exercise. I hope you enjoyed listening to it. And if you want to see more exercises, feel free to visit the rest of the exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.